Hi. Just realized that I didn't make a video for the hard dimensional analysis, so here we go. Uh, blah, blah, blah. They use metric instead of English. True story. These numbers are made up. So 18,944 meters. And, okay, so this is a hard problem. It's not obvious where to start. So, in a case like this, you get to draw a picture. This is the Earth. This is a distance of 18,944 meters. This is your satellite. Looks like a TIE fighter. And then a second group of engineers did it for that many feet. So how much was it off by in meters? All right. So a second group of engineers did it for 18,944 feet. That means feet. Okay, so what is the difference here? Okay, now that I have drawn the problem out, it is not so hard. It's kind of obvious that I just have to do this minus this. But I can't subtract feet from meters. I'm going to change this into meters also. So how do I change this from feet to meters? Well, let's see. I know that there are for 1 times 10 to the 2, negative 2 meters, there is 1 centimeter. I usually just say 100 centimeters is 1 meter, but a lot of people prefer it if I stick to this convention where I put the 1 on the thing with 2 letters and put the exponent thing on the thing with 1 letter. A lot of people like that better. So that's the meters, and now I know that there are 2.54 centimeters in 1 inch. I'm just getting rid of stuff here. And I know that there's 12 inches in 1 foot, and I've got this many feet, so 18,944 feet, right? So that will give me this number in meters. So I'm going to replace this number with meters. Let's try Alexa again. Alexa, what is 0.01 times 2.54 times 12 times 18,400? Oh, I messed it up. All right. Never mind. Alexa, stop. All right. Okay, so 0.01 times 2.54 times 12 times 18,944. Okay, that's 5774. But how many significant figures? Wow, that's a lot of significant figures. All these numbers are definitions. This is 5 significant figures. Oh, I need another figure. 57741. So it's 5774.1 meters. All right. So it's this many meters minus 5774.1 meters. Oh, was there a 0.0 at the end of this number? Yes, there was a 0.0. 0.0. Alexa, what is 18,944 minus 5,774.1?
18,944 minus 5,774.1 equals 13,169.9.
Okay, that's it. Now, your problem is going to have different numbers, so you're going to have to do that yourself. I think I'm just going to do all these in a single video. Blah, 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 ozone hole, blah, 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 difference in diameter in meters, year A and year B. Okay, so this is another complicated problem, so I'm going to draw a picture. Ozone hole was a real thing, by the way. Did you know that? Ozone hole, ozone hole in year A and ozone hole in year B. Okay, we want the difference. Okay, so we want A minus B. I don't know which one is larger, so I'll take the absolute value so I don't get a negative number. You can't have a negative sized hole. Or can you? Is there such thing in the universe as a negative hole? Negative matter? I don't know. Maximum surface area. The ozone hole had a surface area of 16.5 kilometers squared. 16.5 kilometers squared. In year B, 27.7 kilometers squared. Ooh, it grew. The hole grew. That's not good. So, we want to get the answer in meters. Huh. Oh, we want the difference in diameter in meters. So this is not an accurate picture. Psst, we need a diameter here. So, we're talking about diameters, all right? Excuse me. Excuse me. Okay, so I want the diameter of A minus the diameter of B. Excuse me. Okay. This one, although it has been advertised as dimensional analysis, only part of it is dimensional analysis. We want this in meters, so I'm going to now change these things to meters. This is a dimensional analysis part. So I know that there are 10 to the 3 meters in 1 kilometer. And I've got 16.5 kilometers squared. So I have to square this whole thing. So that's going to be 16.5 times 1 times 10 to the power of 3 squared. That's going to be 165. That's going to be 16,500,000. So 16,500,000. 16 million. No, that should be a 7. 16,500,000. Okay. That's meters squared. What about the other guy? The other guy is going to be the same thing. That many meters is 1 kilometer. I know I'm going to have to square it. And I got 27.7 kilometers squared. That's what I got. I think you got different numbers. All right. So this is really going to be the same thing. 2.77 times 10 to the 7th meters squared. Cool. So do I subtract them? No, because those are areas, meters squared. I want the answer in meters. So I'm going to have to figure out what the diameter is for this area. All right, so this was an area for A. And down here, this was an area for B. All right? So, what is the diameter for A? Well, remember that the area equals pi r squared. And the r is half a diameter, or 2 radiuses makes 1 diameter. So wherever you see radius, you could just solve this equation for r. So r equals half of a diameter. All right. So wherever you see r, you can just put d over 2. Oh, here's r, so I'm going to put d over 2 right there. All right. So area is really pi times d over 2 squared. All right. So there is no way that I know of. No, actually, there is no way to get the d using the dimensional analysis that we've used up here, because this stuff is all multiplication and division, but to get the d, we need to take a square root. There's no dimensional analysis problem that we do in Chem 10 where you take a square root. So this is a little bit advanced. All right, so I know that the area is this, 1.65 times 10 to the 7th. So 1.65 times 10 to the 7th meters squared is the area, and that is pi times d squared over 4, because 2 times 2 squared is 4. Now I'm going to get the d alone, so I'm going to divide both sides by pi. That gets rid of this, and multiply both sides by 4. That gets rid of this. And then I'm going to take the square root of both sides to get rid of the squared. And that is going to be the diameter. So the diameter is going to be equal to this stuff. So this stuff, oh good, I still have this number in here. That's nice. This stuff is going to be multiplied by 4, and then it's going to be square rooted. Where's that shift button? Oh, here we go. Square rooted. So I got 8124. Actually, 8120 for sig figs. 8120. Only 3 sig figs there. All right, so that's how many meters diameter A is. I'll do the same thing for diameter B. In fact, I'm going to do it right now. Can I get some room here? is there some, yeah, there's more room right there. Okay. Diameter B. So the area of the B was 2.77 times 10 to the what? 7th meters squared? Yeah. So, and that is equal to pi r squared. But remember, we're not using r, we're using diameter. So that's pi and half a diameter squared. All right. So 2.77 times 10 to the 7th equals pi times half a diameter squared. Oh, you know what? I forgot pi in the previous calculation. Because I'm so messy, I forgot about the pi, so this is not the answer. Here, let me do that right. It was 1.65 E7 times 4 equals divided by pi. Okay, and take the square root of that. Okay, 4583 or 4580. So it's 4,580 meters for my problem. You have different numbers, so yours will be different. Okay, and now I will solve for the D by dividing everybody by pi. That gets rid of this pi, and multiplying everybody by 2 squared, which is 4. So that's going to get rid of this guy. All right, so then I have to get rid of the squared, so I'm going to take the square root of both sides. Okay, so the D equals the square root of 4 times 2.77 times 10 to the 7th meters squared divided by pi. Now, square root of meters squared is meters, by the way, so that's a nice little a reminder that you're doing the problem correctly, or confirmation that you're doing the problem right. 4 times 2.77 10 to the 7th divided by pi, and then square root 5940. So diameter of B is 5940 meters. All right, so because I drew the problem, I know what to do next. It's in the picture. Here's my picture. So I have a diameter. Oops, sorry. I have a diameter here. That's what this line means. A diameter here. So the difference of the diameters is going to be 5940 minus, who is the other guy? 4580. Alexa, what's 5,940 minus 4,580?
5,940 minus 4,580 is 1,360.
1,360 meters. That's the difference of the diameter. So that's how you do that. Yeah, it ain't easy, but that's you didn't sign up for Chem 10 because you wanted to take it easy. That's what your friends are doing over there on the beach. That's not you. All right, black hole problem. This black hole problem. Actually, you know what? I have a video that I made for somebody on the discussion board about this problem, I think. So I will just put that up on here. What about this? This is an easy problem. I'm not sure why I put this on the hard dimensional analysis homework, but you're going to Los Angeles at we're talking about. I forgot to put the word tectonic. Somehow the word tectonic plate disappeared from here. I'll put that back in. So the tectonic plate that the Pacific Ocean is on is moving towards Los Angeles at a certain rate, and that's the rate. How many seconds will it take us to reach Los Angeles, which is... Oh, okay, so, sorry, the tectonic plate that Santa Monica is on is not the same tectonic plate as the one that Los Angeles is on. So we are actually moving towards Los Angeles at this rate. So how many seconds will it take us to go that far? So let me do that. So 0.04 and 640 kilometers. Where is it? Here it is. Okay, so I want to know how long it will take. Do I want years? No, I want seconds. Oh my God. Okay. So I know that there are 60 seconds in 1 minute, and I know that there are 60 minutes in 1 hour, and I know that there are 24 hours in 1 day, and I know that there are 365 days in 1 year. Why do I have to do all that? Because the .040 is in miles per year. Okay? So I'm going to get rid of the year like that. So 0.040, oh, not like that, sorry. It's 1 year we move 0.040 miles, okay? So years cancel, days cancel, hours cancel, minutes cancel, and seconds are left. Now, miles. So we're supposed to, so the object of this game is to move 640 kilometers. Is that what we wanted? Whoa, Santa Monica is not 640 kilometers away from Los Angeles. Huh. Oh, I guess this is about something else, not what I thought it was about. But anyways, 640 kilometers is what you have to calculate. So, okay, so how many miles are there in a kilometer? In 1 mile, there are 1.609 kilometers, all right? And now I got to get rid of the kilometers. To get rid of that, I put the 640 kilometers. This only has 2 sig figs, by the way. So kilometers will cancel. And now I'm going to do, Alexa, what is 60 times 60 times 34 times 365 divided by 0.04 divided by 1.609 times 640? Oh, she couldn't do it. She choked. Okay. All right, I'll do it myself. Okay. Okay. 60 times 24 times 365 times 640 divide 0.04 divide 1.609. Okay, so I got 314. Well, I'm going to do 2 sig figs here. So 310, this is million, this is billion, 310 million years. So in 310 million years, no, billion. In 310 billion years, I don't know if that was, yeah, that's right. In 310 billion years, no, seconds. See, years was canceled out. And this problem is about seconds. It will take 310 billion seconds for something to move 640 kilometers at a rate of 0.040 miles per year. Crazy. Who comes up with these problems? Jeez. Okay. Now that's it for this video. But I am going to put a few words in here to make it make actual sense.